So I think this is our second lesson, is it? No, no. This is our third lesson. And then uh so this will be the last lesson teaching the mathematics, okay? I think I skipped the trigonometric function. So maybe let's talk about it when we are going to use it. When we use it, and then we talk about the trigonometric functions. And then so let's start. We are going to talk about the binomial expansion and also the Taylor series. So first of all, what does mean by binomial expansion? So let me draw a pen. For a binomial expansion, so that means, let's say if you want to expand this one, a plus b to power n, and n is a natural number, okay? So that means it's a positive integer. And then we want to have uh, we are not just go, let's say n is very large. We don't want to expand it by our hand. We want to have a shortcut to expand it more easily. Then will we skip that? Oh, sorry, what do you mean by the slides for vector part 2? Yeah, what do you mean by the slide part 2? Oh, okay, you asked me in WhatsApp, okay, later on. So let's try to define one first, okay? This is called the factorial, okay? So I'm not I think most of you haven't learned about it yet. So for factorial, n should be a natural number or zero. So n is an integer that is greater or equal to zero. To define n factorial, that means it's n times n minus one, and then go on to times two and times one, and then one factorial and zero factorial is defined as zero. Is defined as one. Okay. So just for example, 3 factorial is just 3 times 2 times 1. 4 factorial is just 4 times 3 times 2 times 1. Okay. So not difficult to understand that n factorial can be written as n times n minus 1 factorial, is it? Because n minus 1 factorial is n minus 1 times n minus 2 and up to 1. Okay, so this is how we define a factorial. And in a binomial expansion, we need to also define the, I should write down right here, okay? The combination. Combination is NCR. You can write it like this. You can write it like this. You can also write it like this. Okay, there are different method to write down the combination. So I think can anyone tell me what does the combination mean? What is the meaning of the combination? George, I think you can do it. Is it?
Is the number of times you can arrange objects or things
And then
without it repeating.
okay, so
Or the order doesn't matter.
yeah, so it's the number of the order. Okay, sorry, that there has n objects. Okay, n distinct object, and then you take uh k object each without it at a time, without repetition. I'm not going to tell you teach you why they are equal to each other. Why we can write it like this, but just give you the idea. So let's say there are n people, okay, n people. So let's say if you want to form a team of K people. Okay, of course, you know every person is distinct from each other, so uh, they are distinct objects. And then you are finding the number of order, okay, or the number of combination that can be formed, or the number of teams that can be formed. Okay, so the n factor, the combination NCR is defined as n factorial divided by r factorial times n minus r factorial. Okay, this is how the combination is defined. And in this case, okay, n should always greater or equal to r. Okay, and also r should greater or equal to 0. So r cannot be smaller than r. So r cannot be larger than n. So this is how the combination is defined. So if you like, actually we last year we have the HKOI training. Okay, we talked about the combination last year also. So if you like, I can send you a link for the videos last year, so you can have a look at it, and also you can join the combination later on. George, when is the combination last year? Is it in
Um,
September?
yeah, I think it was. I think it was supposed to be in July, but I think they moved it to like October. I think, or yeah,
July?
it was supposed to, but they because of the
Oh,
coronavirus, they had to move it.
okay. So last year commission is in October, is it?
I think
Oh,
so.
but this year has not the re, uh, uh, there's no announcement for the coming
Yeah.
commission. So we don't know. But I think if you like to join, you should study it in the summer. So let's move on. So for binary expansion, so let's have a look at the Pascal triangle first. Okay. Pascal triangle. So it's 1 1 1, 1 2 1, 1 3 3 1, 1 4 6 4 1, 1 5 10 10 5 1. I think you are able to find the pattern of this triangle, is it? So you know every let's say this number is the sum of these two. Okay, 6 is the sum of these two, 10 is sum of these two, and so on. So why we draw the Pascal triangle, like because when you're doing the binomial expansion, let's say a plus b to the power 0. Okay, you know this is equal to 1. If a plus b to the power 1, you get a plus b, and then if a plus b to the power 2 is a squared plus 2ab plus b. If you know about a plus b to the power 3, it's a cubed plus 3a squared b plus 3ab squared plus b squared, and so on. Actually, I think you are able to look at the pattern in this formula. Is it 1 1 1 1 2 1 1 3 3 1? And also is I think if you try to understand, so let's say a plus b to power 3. So you can write it as a plus b times a plus b squared. So that is a plus b times a squared plus 2ab plus b squared. Is it? And then you can expand it like this. So you can expand it like a times this thing and then b times this thing. So let me try to write down. Okay, so a times this thing can be written as a cubed plus 2a squared b and then plus a b squared. And b times that bracket will becomes a squared b plus 2a b squared plus b cubed, is it? And then if you look at the coefficient here, okay, so it's 1 2 1 and this is 1 2 1. So you know it become 1 3 3 1. And it's one method for you to understand why it's 1 3 3 1 here, because it just looks like it's 1 2 1, and then you put another 1 2 1 here and add them up together 1 3 3 1. And then if you're not doing this, you can say it's 1 this number is just you just copy the one on left hand side, and then the 3 is the sum of these two numbers. I think you can understand this, is it? The 3 is the sum of these two numbers, and then so on. Okay. Uh that's it for this part. But if you want to try to prove this one, you can also use the mathematical induction. Have you learned it in Form 4 or GCSE? Mathematical induction.
Not yet.
Yeah. Okay. Then I think June and George can prove it. Okay, as a homework. Okay. Okay. So let's move on. So then we are going to prove another formula that is NCR. Okay. Uh, so this will left as a homework for you to prove this equation. To prove this and identity. So this also gives you the idea why this number 3 is 1 plus 2. So because we use this identity, and then we can find the value of this one. Da, 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 da. Okay, but I haven't tell you the formula for the binomial expansion yet. But actually, we are not going to use it so often in the convention, but just teach you in case you need it. So a plus b to the power n can be written as, if I'm using a summation sign, the formula will look like this one. Uh, I think some of you have learned about the summation sign already, but most of is it? Have you? So let me ask you again. Have you learned the summation sign by yourself or from the textbook? Okay. So right now you know that, okay. You haven't learned a lot of mathematics in the school, so you need to catch up. Okay, really catch up. Otherwise, don't waste your time to study those easy mathematics. Okay, so learn it more by yourself. So there's a call. Let me uh stop for a while. Okay, stop for a while. It's so annoying. It's so annoying. The call is so annoying. So let's continue. Okay, so when you expand it, oh sorry. So you get nc0, and then a to power n, r to power 0. So what does summation sign mean? So that means uh, it is a series of many terms. So the first term is starting from r to 0, okay? The first term starting from r to 0. The second term starting from r to 1. So it depends on the starting number here. So this is the n number, okay? So that means the last term, the r will be substituted to be n. Okay? The first term r will be substituted to be 0. 1, 2, 3, 4, and up to n. That's the meaning for this summation sign. Okay, let me write down a few more terms. Then I hope you can understand this one. Also write down the last two terms. Oh, sorry, it's B here. So I hope you understand. Uh, and then I would like to also rewrite this formula, because if you derive it from the definition of NCR, this one will give you 1. This one will give you n. This one will give you n times n minus 1 over 2. And then this one will give you n, and this one will give you 1. Sorry, I need to also introduce another identity here. So also left as a homework for you to prove it, okay? So then overall, so let me write down the final formula in this page. So that is the a plus b to power n equal to a to power n plus n times a minus a to power n minus 1 times b. So the sum of the order of a and b should always be equal to n. and then it's n times n minus 1 over 2 and a n minus 2 to b squared. I think you understand how this one come. I think write down the next term and then I think you can understand the pattern behind. It's over 2 times 3, okay? And then you multiple one more terms here, that's n minus 2. Then the last few terms is this one, and then plus b to power n, and so on. So, but the problem is, how about if n, now, we talked about this already, okay? So n should be a positive integer. So n should be a positive integer. It can be 0, it give you 1. But how about if n is negative or n is not an integer? So then we will have some approximation here. So let's say for 1 plus x to power n, okay? We always use approximation in physics. You know, physics is an experimental subject. So we don't need to get a very, we don't need to get, we don't always need to get an accurate value. Because if you say that you can measure the length up to, let's say, 2.111122334 and so on, okay? It's useless because we may not have that apparatus to measure up to this precision. So it's useless. Sometimes it's useless to get the value of to get an very accurate answer. We just get the answer up to certain precision. That's enough. So sometimes we are doing the approximation to help our calculations. Maybe let's say if you put in the computer, you can also help uh, reducing the running time to get the answer. So to do the approximation, let's say for this one, okay. So if n is an integer, okay, and then obviously, okay, a equal 1 and then b is an x. So it gives you 1 plus n x and then plus m times n minus 1 over 2 and x squared and then so on. Okay, I didn't write down the last term, okay. But in this case, actually, I would like to assume that x is much smaller than 1. It can be 0.1, that's fine, okay. At least x should not be 0. X is less than 1, okay. At least x is less than 1. It's still fine. So if x is less than 1, if x is much smaller than 1, then we can write x 1 plus x to power n is approximate to be equal to 1 plus nx. Because if you compare the term x squared and then x, so let's say x is 0.01, then x squared will become 0.0001, then it's 100 times much smaller than x. Then later on, x can be negative also. Right? X can also be negative. And then later on, for x cubed, x to power 4, those terms will be much smaller. Then those terms we can negate. Okay, we can negate those small terms. So in approximation, we can write it as 1 plus nx. But sometimes, 1 plus nx is not, this approximation may not be good enough. We may also need to take this term. I'll tell you when we need to take the take this approximation. Okay. Sometimes we need to take the approximation up to x squared. Okay. Then let's move on. And then so I would also like you to do this one. Okay. How about n is negative 1? Now if n is negative 1, we can still use this formula to find the expand x 1 plus x to negative 1. So if you do it and then you get a very interesting series. So that is 1 minus x plus x squared and then minus x cubed. plus x to the power 4, and so on. So actually, if you don't believe in me, you can do it by long division. I'm not sure if you have learned about the long division already. So you know x 1 plus x to the power negative 1, that means 1 over 1 plus x. Okay, so you get 1 first, okay, and then minus x. Then what you need to try to get rid of negative x, negative x, and so on. Okay, you can show that. Okay, quite easy. So this is the first approximation that we are going to use, and uh, you can get some try by using this approximation. So let's say 1.01 to power 5. So if I use this approximation, then we'll get is the value will be approximate to 1 plus 5 times 0.01, is it? And then you can use your calculator to get the value of 1.1 to the power 5 to see what value to get. Mhm. Okay. The value you should get is around 105, 101, 00501. It's close enough, is it? It's close enough. So remember this approximation. Uh I will remind you again when we are going to use approximation, or we are going to use this approximation soon. Almost in the last chapter. Okay. Then the next thing we're going to learn about is a Taylor series. So this is a we haven't learned about the differentiation yet, but we are not going to learn it for this combination. And for Taylor series, it's just say that any well-defined function, okay, uh, can be written as a series of infinite series of polynomials. Actually, the form will look like this one. Okay, the form will look like this one. The prime means differentiate ones. Okay, differentiate ones, and this is an infinite series. And then we are going to learn or we memorize some of the Taylor series. So the first one we're going to learn is the sine x. Now here the x is in radian. If you haven't learned about the radian, let's talk about this later on. So the sine x, you can think about how your calculator calculate the sine x. It cannot store all the value of sine x in your calculator. So it make use of the series, this Taylor series to calculate it. So you change sine x to a polynomial, and then oh sorry, I hope you can guess the next term. Is it plus minus plus and then minus x to the power 7 divided by 7 factorial and so on. So this is the Taylor series of the sine x. And then we are going to also have a look at the Taylor series of cosine x. If you have learned about the differentiation, okay, you can do the differentiation here to get the Taylor series of the cosine x. The form look like this one. The form look like this one, and so on. Okay. You may wonder if there is a very beautiful form for tangent x. The answer is no. I'm not saying we can't get the series of the tangent x, but if you want to get the series of tangent x, you can use a Taylor series to do it. But the differential here is not easy to get. And you can also do the long division. You know tangent x is sine x divided by cosine x. You can also do the long division of these series divided by this series. Then still can get the series of the tangent x. Uh, we just need to learn one more Taylor series. That is exponential x. And so on. Okay, so this is the exponential x. Uh, you have seen this e before, I think. Is it? In the last lesson. So this is Euler's number. So this is a number that is used very often, very commonly used in science and engineering. So by looking at this Taylor series of the exponential x, I think you can understand if you know about the differentiation. You can understand why you differentiate ex still give you the ex. And then you can also show that by using the Taylor series of the sine x, cosine x, and ex. You can also show that the e to power ix equal to cosine x plus I sine x. Okay, it will be left as homework. Okay? Ha ha ha. So every difficult proof are left as homework. Right? Very good. So these are the Taylor series that you may need to know about it. And then we you don't understand which one. Okay, we are not going to. I just give you the result because we didn't I didn't teach you how to do the differentiation. Okay, so I will just let you know the result only. But we are not going to. You can learn Taylor series later on by yourself. But we are. I'm just going to. I just go to show you the result. Which one? What do you mean by RHS equal to? Yeah, they all equal to each other. They all equal to each other. If you get the sum of the to the infinite terms. Okay. Then last thing, okay, last thing. Now, we always look at the formula, and then we always want to get some approximation. So if you look at the form of sine x, cosine x, and e to power x, so the order of x increases to infinity. So that means if x is very small, x cubed or x squared will be smaller, and then x to power 4 or x to power 5 will become much smaller. Then we can do some approximation, just like 1 plus x to power n. So for sine x, if x is very small, you can approximate to be equal to x. Okay. If x is much smaller than 1, then sine x is approximate to x. And then cosine x can be approximate to be 1, but it's not. You can't approximate everything to become a constant. So you also we I'm also taking the second term. So approximate to be 1 minus x equal to 2. And then e to power x can be approximate to be 1 plus x. Okay. Remember that the x in the sine x and cosine x should be in radian. They are not in degree. Okay. So you can't say sine. If you say 0.1 degrees very small, it's not equal to 0.1. Okay. In your calculator, you need to change it to radian mole, and then you can see that they are very close to each other. So these are the approximation that we are going to use later on. And then, so this is a short chapter. And then we are going to learn the next one. So that is the, uh, let me save it first. And then we are going to learn the next one. So that is called the dimensional analysis. So this is also a very important chapter. If you have no question, then sorry, let me delete something first. Oh, okay. So let's start. Uh, if you are going to study the GC syllabus, the first chapter is about the unit and also something like the dimension analysis. So, but they don't use this term. They call it checking the unit, something like that. So first of all, let's learn about the prefix of the unit. Like, all the question paper, most likely the question paper are using the SI unit. Just some exception case, let's say for kilometer per hour, because it's so commonly used. So, but you need to know how to change it to meter per second. So these are the prefix of the units. You need to memorize all, but you just can forget some of it. So this is the you don't need to know about it. You don't need to know about it. Okay. Then the others all you should all know about it. Okay. Just some trick to memorize it. Okay. So let's say for you, using the computer. Okay, the storage unit is the smallest storage unit is the byte or the bit. Okay, and then the next one is a kilobyte, megabyte, and then gigabyte. Okay, so these are the symbols here, and then the next one, of course, is gigabyte. Okay, then you can memorize this already. Okay, 10 to the power 3, 10 to the power 6, 10 to the power 9, and 10 to the power 12 here. And then for the smaller one, okay, uh, there's no trick to memorize it, so you just need to memorize by yourself. And D is also used in chemistry, but it's not used commonly in physics. Okay, in chemistry, you know the big M. That is a unit of the mole. Oh, sorry, this is a unit for the concentration. It's defined as mole per dm cube. As I remember, but my chem is not that good. Okay, then let's move on. So then let's talk about what does mean by dimension. Dimension is not like the three dimension. The dimension here does not mean the three dimension. The three dimension space is not like that. Okay, the dimension here is something look something looks like a very similar to unit. But we will say that the kilometer and meter they are uh they are different units. Is it? I think they are different units, but they measure the same thing. They are also the unit of length. They used to measure the same quantity, the length. Okay, so we say that they are the same dimension. They have the same dimension. Okay, and meter and second, of course, meter and second are different. They are different units and also different dimensions. One measure the length, one measure the time. Then let's move on. For the equations, okay. So in physics, okay, if you want to add two numbers or do a subtraction together, you need to make sure that they have the same dimension. So that means, uh, you, uh, 1 meter, you can't add 1 meter to 1 second. It's invaded or it's meaningless. Okay. Or you can call it a dimensional invaded. Okay, dimensionally invaded. And also, 1 meter cannot be equal to 1 second. It's also dimensionally invaded. Okay, so this is what you need to bear in mind. So then, why we are going to learn this dimension analysis. So let's say, for example, I'll give you an example later on. Okay. So then let's move on. So in now we only have 7 fundamental dimensions. Fundamental means all the others can be derived from these seven, or the combination of these 7 fundamental dimensions. So let's say the current. Okay, there's a current. Current is a fundamental dimension. Let's say charge. Charge is defined as current times time, and it can be derived from these 2 dimensions. So acceleration is, the unit of acceleration is meter per second square. Is defined as the dimension of the acceleration is just length over time square. Okay. Then the next most likely we are using the symbol for the dimension, like it's yeah, it's just like the light intensity, but you are not going to use it very often in physics. So for this commission, most likely you're just going to use the dimension of length, mass, and time, because it's just about the mechanics. Current is about the electricity, or the actual topic of electromagnetism. The temperature, of course, is about the topic of heat. Amount is about the topic of heat, also it's in the gas. And then we are going to just use these three in mechanics. So that means most likely all the quantities will have the dimension of the combination of length, mass, and time in this commission. So the rules of dimension, we've talked about this already, okay? So we don't need to talk about this one. Uh, so the application of dimension analysis, there are 2 applications for it. You can check whether the equation is dimensionally valid, and this can also help you to check your answer. Okay. So what do I mean? So let's say I can't give you a concrete example. Just for example, let's say the question asks you to calculate the length or the distance of the path, whatever. So the question may be very complicated. Okay, it involves many terms, many quantities together, and then if you keep on to use a symbol in your calculation, I hope you understand what I mean. So let's say for the area of this rectangle, okay, A is 1 meter and B is 2 meter. So most likely in your first step you say area is 1 times 2 and then you go 2. But in physics, I'd rather you use a symbol to do the calculation first. So that means you write down as A times B first, and then in the last step, okay, almost in the last second step or the last step, then you substitute the values in the in the formula. So why I need you to do so? Because if you do it like this, you can check whether your answer is dimension valid or not. So let's say for length, if your final answer using the symbols, okay, the almost the last step, using a symbol to represent the answer. Let's say if you write down something like v squared times t, so v is the speed, t is the time. Then if you check the dimension or check the unit, whatever you call it, so v times t, v times t, the speed times time is the distance. It has a unit or the dimension of length or meter. And then but here is v squared. So what does it mean? V squared times t does not have the dimension of length. So that means most likely, or 100%, or you can say 100%, your answer is wrong. Okay? Your answer is wrong. Your answer does not have the same dimension as what you want to find. That means your answer is wrong. And then you need to redo the question again. But if you substitute the values in the beginning, you cannot check your answer by using the dimension analysis. what you would like to say is, let's say v is 1, t is 2, or you just say 2 meter, okay? You can't check your answer using the numbers, okay? But you can check the dimension using a symbol. So this is very powerful tool for you to do the question. Maybe to check whether your answer is correct or not. Most likely, if I mark your homework, okay, I'll check the dimension first. If the question is quite complicated, then if your dimension is wrong, then I'll just uh, put a big cox, and then I just don't mark it. Okay. So and then the second application is to guess an equation, but most likely you're not going to do it because most likely you know the equation for the commission. So then let's give you one example. So this is the formula that you are going to learn it in next lesson, most likely. Okay, I'm not sure if we can cover this equation in the next lesson. So for the form, I think none of you have learned about it in your textbook. So this is a formula in the GC or in Form 4 DSC. So S is a displacement. Then you know S has the dimension of length. We use a symbol L for length. So that means on the left hand side, okay, the dimension is length. And then let's go to check the U times T. U is a speed, T is a time. So speed has a dimension that is length for time. Time has a dimension as time. Okay. Length for time times time give you length. Okay. And then let's check the next one. This one. Now, 1/2, this is a number only. It, it has no dimension. Whenever you see a number there, the number has no dimension. You can say it as 1. Okay. And then A is the acceleration here in the formula. A has a dimension that is length over time square. And then T is a time. So T square is a dimension is T square. And then okay, you simplify it, you still get the length. Remember what I told you, okay? If you want to do the addition, only the quantities with the same dimension can do the addition or subtraction. And okay, on the left right hand side, you can see it's length plus length. Okay, that's fine, it's totally fine. They have the same dimension, so you can add them up together. And then when you add length and length together, you still get the length. And then on the left hand side, still the length. So that means uh, this is in this equation is 100% dimensionally weighted. Okay. Now, although we can't tell whether this equation is correct or not. So let's say give you another example. Let's say there's another equation like s equal to ut plus at squared. Okay, without the constants 1/2. You may say if you check the dimension at squared, you still have the dimension of length. It's still dimensionally weighted for this equation. But you may wonder which one is correct. Now we can't tell which one is correct uh, by just using the dimension. Because we are not going to guess the equation in for all the physics formulas. We are 100% not going to guess the equation. What you can do it is either you check whether you can derive it from other equation. Whether you can derive it from other equations, or you can do the experiment to check which one is correct. Okay. So in this case, actually, the left hand side, this one is correct, and this one, although it's dimensional weighted, but and it's not a correct formula. Okay. So dimension analysis is quite powerful for you to check the formula. And I encountered one case in exam. I mean, in the exam in university. The question is to prove one equation, one formula, and then I can't prove it after let's say 10 minutes or 15 minutes, and then I check the dimension. Okay, the dimension on the left hand side is not equal to the dimension on the right hand side. So that means the formula is dimension invaded, and I told the professor, and then he of course he understand what I mean. Okay, and then he also checked the dimension, and then after checking the dimension, he knows he get it wrong. So that means Okay, and then he just changed some of the quantities in the formula, and then yeah, and then he correct the mistake in the exam. So this is one accident I encountered in my study. Okay, so this one is another this is a past paper from the Hong Kong Physics Olympiad. So this is an MC. For MC question, you can actually check the dimension of the choices you are given, and if it is dimensionally invaded, you can just eliminate the choice. Okay, so in this question, actually you can eliminate three choices out of five, and then finally you can do this question very sim. If even if even if you don't know how to do this one, you still can guess it. You have 50% chance to get it correct. So it's quite good. So let's have a look. Although you don't know about what this question means, so it's still fine. So we just let me tell you from formula. So that is FUKX. S is the force, F is the force. Okay. K is a K here. This is a force constant. X is the length. It has a dimension of length. A spring constant or force constant. And then force can be written as Fu and you know about it. Okay. Then what I can do is, let's say, and then we know that, okay, so K over M, okay, K over M equal to A over X, okay. So K over M has the dimension of A over X. They have the same dimension, okay. And then you know K plus K still give you the dimension of K. So that means K1 plus K2 over M has the same dimension as A over X. But you can look at the choice. It is K1 plus K2 over M plus A or minus A here. So can you do the addition or the subtraction of A over X minus A or minus plus A? You can't because they don't have the same dimension. Okay. Then you can eliminate the choice B and C. Yeah. So good. Yeah. So that means okay. And then look at the choice E. Sorry. Look at the choice E also. And then this is a bit complicated, but let's have a look at its dimension. So it has the same dimension as k times k over k plus k. K plus k still have the dimension of k times the mass m. So it can cancel out one of the k. And then, oh, that means it still have the same dimension as k over m. You still can't do the you can't add it to a. So that means this equation, the thing inside the square root is dimensionally invaded. So that means you can cancel out the choice B, C, E. Finally, actually, if you want to do this question and then you know these two springs are connected in series, then you can easy to get the answer to be D. Okay, so this is one of dimension analysis is one of the very powerful tool for you to guess the choices of the MCs. But of course, if the choices are in numbers, so let's say 1, 2, 3, 4, 5, you can't check the dimension. You can't use this method. If the choices are in symbols, then you can check it. I will also teach you some other skills uh, in MCs if the choices are in symbols. Okay. Then let's move on to next case, next example. So this is the S radius, okay, S dot radius. So this is the name of a question. So this is any object whose distance to the black hole is less than this radius cannot escape from the black hole. So this example is tell you how to guess the formula by using dimension analysis. So let's say this is a black hole. At the center, this is a black hole. Okay, and then what does distance mean? So this is within this region or within this sphere, any object uh, if if an object is in within this region, it cannot escape from the black hole, no matter how fast it moves away from the black hole. So then, so first of all, how can we guess the formula for the this radius? So you need to think about the factors or the quantities that will that the radius depends on. Okay, so but I give you here. Okay, so it may depends on the mass of black hole. Maybe let's say the more massive the black hole is, then it's more difficult for the object to escape from it. Is it? Yeah. The next one is the universal gravitational constant. When we talk about the topic of the gravitation, then you know this constant will be it will this constant will go through the whole chapter. And then the next one is the speed of light. Because in other words, okay, this radius can you say the within this region, no light can escape from the black hole. So that means it absorbs all the light. It can absorb all the light. So it appears black if you're looking outside. Okay, so it's another definition of black hole. So it depends on the speed of light. So then let's guess the equation. So because most likely we'll guess it. The radius r. Let's say this is m, this is big G, this is c. Most likely you guess it as some equal to some constant times mass to some power. Okay, I use alpha times g to some power, and then times c to some power. Oh, sorry, it should be alpha, beta, gamma in sequence. Okay, in sequence. Okay, or you can write it like r is proportion to mass to power alpha, g to power beta, and then c to power gamma. Then we are going to use the dimension analysis to guess the formula, to get the uh, closed form of this formula. So starting from the r, okay, equal to some constant. Okay, let me delete this. Constant has no dimension, just remember it. What's the first one? It's the mass, is it? And then g, is it? And then let's have a look at the dimension on the left hand side. It's radius. That means it should have the dimension of length, L. M is the mass, of course, it has the dimension of mass. Okay. C is the speed of light, so it has the dimension of as length over time. Okay. G is a constant, but it also has a unit. Uh, you you may not know the formula. Uh, if you know about the formula of G, you can just use any formula con that contains the G. So let me use the most common one. So that is FUG, product of the mass over r squared. R is a rate distance. So and then make G be a subject of this formula. Okay. Then we just I don't remember the dimension of G also. So I just do it from this equation. So R is length. So R square has a dimension of length square, and then the denominator is mass times mass, so it's mass square. And then I further break down the force by using the formula MA. And M has a mass, N has a dimension mass. A is the acceleration. It has a dimension that's length 4 times square. Okay, and then you do the some simplification, and then you get this as m to power negative 1, length to power 1, sorry, length to power cube, length cube, and then time to power negative 2. Okay. A similar, just change it to length per length lt negative 1. Okay. Later on, I think you should able to derive the dimension by yourself if you learn more formulas. Okay, then let's go on. So because I want this equation to be dimensionally valid, so that means the dimension on the right hand side should equal the dimension on the right hand side. So that means L should equal to, this is just the dimension of M only, not M to power alpha. So M to power alpha should have the dimension as mass to power alpha. And then it's M left 1 length cube divided by time square to power beta. And then LT minus 1 to power gamma. Right? And then what you do is just expand everything on the right hand side and simplify it. I mean, do it a little bit fast, maybe, but I think you still can do it by yourself. I hope I get it correct. Okay. So then what I can do next, I just compare the coefficient on the right hand side and left hand side. So on the left hand side, it's just L. So you know L, that means L to power 1. So if you compare the coefficient, so that means 1 equal to 3 beta plus gamma. So I think it's straightforward, is it? And then the next one is, how about M? There's no M on the left hand side. So that means it's actually M to power 0. You know M to the power 0, that means 1. So that means 0 is equal to alpha minus beta. And similarly for the time, so 0 equal to negative 2 beta minus gamma. And then you are going to try to solve these three simultaneous equations. You can try it later on by yourself, but let me just do it for you. In in the combination, you may encounter the question that you need to solve simultaneous equation, maybe 7 or 6 simultaneous equations. So I think you have you should have the logic to solve it. Okay, so because in this three simultaneous equation, there are three unknowns there. If you look at the second equation, uh, only the second equation has the unknown alpha. So that means this equation should be used in the last step because you can't find alpha in the other two equations. You can't use simultaneous equation to solve it. This equation can give you the value of alpha, but it can't help you to solve other quantities. So then in this case, we are going to use the first one and the second one to to solve the two unknowns in these two equations. So now remember, in most of the case, I think I get some mistake in their calculations. Is it? Do I get any mistakes in the calculation? No. Oh yeah, no. Yeah, in most of the case, don't use substitution when you are solving the simultaneous equation. Addition or subtraction is always the best. So I can add the second equation to the first equation. So 1 plus 1, so 1 plus 0 give 1. 3 beta minus 2 beta give you beta. Plus gamma minus gamma gives 0. So beta is 1. And obviously you can solve the gamma very easily. So gamma is negative 2. Is it? Yeah. And then you know for second equation is alpha equal beta. So alpha also equal to negative 2. So then finally you can say that the formula should have the form that is constant times m to power negative 2 and then g to power 1 and then c to the power negative 2. But I think I get some mistakes here. So let me have a look. Uh, I always get mistakes in this question. I don't know why. Do you see if I get any mistakes in the question? I think I get this one wrong. So let me check it again. But I think I get it correct. I think I get it correct, is it? But the format is not correct. So I think what I get is R is some constant, and then G over M squared. The format should not look like this one. The format does not look like this form. So let me check again. Yeah, the format does not look like this form. It should be M should be here. What I get for alpha is negative 2. Oh, hey, I'm so dumb. Okay, so I get alpha equal beta, so alpha should equal 1, not negative 2. Okay, so yeah, I get the correct form. Okay, so R is some constant times GM over C squared. Okay, yeah, okay, this is the form. But actually, the formula is R equal to 2 GM over C squared. But you know why? Because we can't guess the constants by using dimension analysis. What you can do is derive it, or you you do the experiment. Okay, so that's it for the dimension analysis. So then also that's it for this lesson. Next lesson we are going uh to the first lesson talking about the physics. Oh, okay, so that's all for the mathematics part. But later on, if we need to use the mathematics, we will still need to go through the mathematics. So then see you on Wednesday night. Any question?
Yes, sir. I'm still confused for the Taylor series.
I didn't tell you how you get the series. I just tell you the result.
So, so the Taylor the right hand side is just
Exact definition. You can say the
the
definition of
you
the.
can okay.
Okay, you can say it is a definition.
So the definition, but also the approximation of it.
You can do the approximation by omitting the infinite terms.
Yeah. Okay.
You just do the approximation by calculating the first few terms.
And so, can the Taylor series is used for for which functions? Any
Uh, right now for this conversion is most likely you are just use it for approximation.
for which ones?
For approximation
Okay.
by looking at the Taylor series. But later on, you study further pure math, you know, you need to learn how to derive the Taylor series by yourself, and then there may be some other application, not just approximation, of course. If no question, and then see you all on Wednesday. Okay.